Dear students, now let us start with our topic further. Yes, yesterday we have discussed electrode cell potential, or we can say cell potential. Cell potential yesterday, as I have written and I told, it is calculated by two ways, that is standard reduction potential SRP and NSRP non-standard reduction potential. So today we will continue with the two bases to calculate cell potential. Now cell potential, before I go for cell potential SRP and SRP, please pay attention here. E cell is also equal to EMF of cell, which is Electro Motive Force. What is Electro Motive Force? The cell potential is possible due to separation of charges, as I told you yesterday. Due to this separation of charges, electrons are driving with the force in the circuit, and this force is called motive force because of the electron, and so electron motive force is termed here as electromotive force, which is none other than cell potential. So cell potential is also termed as EMF of cell, or you can say electromotive force. Now this EMF of the cell, or we can say cell potential, is calculated on two bases. One is standard reduction potential of the cell by non-standard reduction potential of the cell. When I say standard reduction potential, the word itself here will suggest a standard condition. Chemistry is studied on the basis of standard and non-standard condition. So here we will first consider standard reduction potential on standard condition. When I say standard condition, we must know about STP and NTP, which I have already told you in 11th standard. What is STP? Standard temperature pressure, normal temperature pressure, and TP. So now here, as I say standard condition, then temperature should be 298 Kelvin, pressure should be 1 atmospheric pressure, and concentration 1 capital M. Capital M gives us the idea about molarity. What is molarity? Here 1 mole per liter is termed as 1 molar. When the cell is satisfying all these three conditions, then it is termed as standard cell, and the value which we are getting is considered as standard reduction potential of the cell. Now this standard reduction potential is measured by SHE, which is given to us as a measuring device by IUPAC. Now on the other hand, non-standard reduction potential. This means the condition which we termed as standard condition is not fulfilled, not satisfied. You can see here I have written temperature not equal to 298 Kelvin, pressure not equal to 1 atmospheric pressure, concentration not equal to 1 molarity. Not equal to is suggests us that this will give us the idea of non-standard reduction potential. It is very easy, as IUPAC has given SHE, C as a device to calculate standard reduction potential. But to calculate non-standard reduction potential, we need one more methodology which was given by scientist Nernst. Nernst or Nernst, whatever you will give it a pronunciation, but it is calculated by Nernst equation. Scientist Nernst has done a combination of the studies of equilibrium, thermodynamics, and by the use of this two, he has given us a Nernst equation which will help us to calculate the non-standard potential, because the condition is not satisfied as the standard condition. Now when I say non-standard condition, it means not all three at the same time should not be other than the standard. It may be if any one is also not standard, then also the potential which we will get for the cell will not be considered as standard potential. If any one of this is non-standard, that means the whole cell will be giving us the value by the help of Nernst's equation, which is based on equilibrium and thermodynamics. So here again you will have to put little light, little focus on your further studies of 11th standard, where you have studied about thermodynamics and equilibrium. When I talk about thermodynamics, then you must remember about the Gibbs free energy, because we will be need to know about Gibbs free energy, which will help us to reduce the Nernst equation, as well as we will have to know about the value of Q, that is the reaction coefficient. From that we will get the equilibrium constant, and so the combination of little focus on thermodynamics as well as equilibrium will be helpful to us for the Nernst equation. But before Nernst equation, what is C? As in 11th standard I was using this word again and again, that C is a standard hydrogen electrode. How it is prepared, and by it how the other cells potential is calculated. So we will consider and we will learn it with the help of SHE, that is Standard Hydrogen Electrode. Now pay attention, SHE, Standard Hydrogen Electrode. How it is prepared? See the construction drawn over here. This is one half cell taken, in which acidified aqueous solution, hydrochloric solution is taken, whose concentration is 1 molar, and hydrogen gas is allowed to be filled from this outlet, which is at 1 atmospheric pressure. As hydrogen is a gas, it is measured and it is given a standard condition at 1 atmospheric pressure. The temperature here is maintained standard temperature, that is 298 Kelvin. In this tube we see here one foil. This foil is a platinum foil, because platinum is the inert metal and it will not take part in the reaction. But to make them conduct, to make them function, this platinum foil is connected with the copper wire or conducting wire, and the gas is allowed to be filled on this, and here this platinum foil will give its surface for the acceptance of this hydrogen gas. As I told, standard reactant potential is measured at standard condition. You may see here temperature is standard, atmospheric pressure standard, as well as concentration standard. And thus, by the help of this C, SHE, IUPAC has given us a standard reduction potential of other metals. And IUPAC has decided for this hydrogen electrode. This hydrogen electrode is also called a gaseous electrode because it is made by hydrogen gas. Standard reduction potential of hydrogen electrode is equal to standard oxidation potential negative of that cell, and which is taken by IUPAC as a standard 0.0 volt. Here you can say it is taken, it is decided by IUPAC. It is not measured. On this earth, everything is considered by the relative measurement. Even if we consider a chapter first of our chemistry 11th standard, we have come across there a platinum iridium rod in the museum cap, which is termed as 1 meter in length, as well as one such weight is considered as 1 kilogram, and on that basis we are measuring, we are considering the relative length and the relative mass. Here also IUPAC has not measured, but it has decided that all temperature satisfying the standard value of the C, that is hydrogen electrode, at standard reduction potential or its negative, that is standard oxidation potential, is 0.0 volt. And with this help, other half cells are being considered and its value is calculated. Here you can see with the help of SHE, all other half cells standard reduction potential is calculated. As in galvanic cell, yesterday and day before yesterday in two different videos I have shown you that galvanic cell as well as linear cell. Here also you can see a left half cell, a right half cell. You please pay attention here, the left half cell, here left it is standard hydrogen electrode, and right half cell, here it is either you take a zinc electrode or a copper electrode or any other metallic electrode whose standard reduction potential is to be calculated. And we know now, as we have already learned about galvanic cell, that on right hand side reduction takes place, that is reduction potential is calculated. So we will take on this right side the metal rod whose reduction potential is to be calculated. And with this conducting wire and with this conducting wire, a voltmeter is fixed when the salt bridge is connected between these two cells. One is the standard hydrogen electrode and another is the metallic electrode whose reduction potential is to be calculated. Then this salt bridge will start functioning of them and we will get a voltmeter reading which will be considered as standard cell, because hydrogen electrode value as IUPAC it is always 0.00 volt and voltmeter reading will give us the reading of this cell. And if we consider that voltmeter reading is of the cell and hydrogen electrode is 0.00 volt, then whatever the reading is given by voltmeter will be the reduction potential of the cathode. Maybe zinc electrode, maybe copper electrode or any other electrode, and thus all other electrodes value was calculated. And by this the standard potential formula has also existed. Standard reduction potential at cathode minus standard reduction potential at anode. Here when you see E degree cell, this degree symbol gives us the idea of standard reduction potential. That means standard cell potential. And by this the whole series of the electrochemical has been developed, which is termed as electrochemical cell. Before going to electrochemical cell, here I would like to say and I would like to show you how the standard hydrogen electrode is represented as platinum/hydrogen gas, hydrogen ion, half cell at 1 atmospheric pressure and 1 molar. Dear students, if you know and if you remember in 11th standard, I have helped you how the cell is represented. Always on the left is anode, always on the right is cathode, and separating to them is two slabs, that is giving us the idea of the salt bridge, right? So now again further I am going to help you how the electrochemical cell series is generated by the help of that is SHE. Different all the metal electrodes potential is calculated, and then that electrochemical series is given in the tabular form in our textbook. Somewhere I will help you how to remember it, but don't worry for its value because all the time value will be given for the calculation. Electrochemical series. It is already given in the textbook, electrochemical series, and in which fluorine to lithium, which gives us standard reduction potential. Standard reduction potential, these are certain significance I have written here. Even I will upload in notes also, but once you please pay attention. Standard reduction potential whose value is more for the standard reduction potential, that particular half cell undergoes reduction and it will be considered as good oxidizing agent. reduction potential is less, they will undergo oxidation and will be considered as good reducing agent. Standard reduction potential, if you will see the textbook Electro Chemical Series table, you will find out fluorine is attaining the highest standard reduction potential and lithium is attaining the least reduction potential. Fluorine, it is highly interested to take the electron. We know it is the highly electronegative. So, its reduction potential is most positive and that is plus 2.87. And so, fluorine is considered good oxidizing agent. Whereas lithium is metal. It is electropositive. Not much interested to take the electron. So, its SRP is most negative in the electrochemical series, that is minus 3.05, and so lithium is good reducing agent. Thus, ECS, Electrochemical Series, help us to calculate the standard potential by the help of standard reduction potential of the half cells in the relation of SHE, Standard Hydrogen Electorde. As for example, here I have shown you as per the Daniell cell. When I say Daniell cell, now you must remember a cell prepared, galvanic cell prepared by taking the electrode zinc and electrode copper. So standard cell potential, that is E degree cell, for the Daniell cell is equal to, as per the formula, reduction potential standard cathode minus reduction potential standard anode. In Daniell cell, cathode on the right side is copper and anode on the left side is zinc. If you will see the table of electrochemical series, the value which is given by the help of hydrogen electrode is 0.34 standard reduction potential for copper and minus 0.76 standard reduction potential for zinc. If we will put this value into the formula, we will get the cell standard potential for Daniell cell is 1.1 volt. Thus, electrochemical series help us to calculate standard cell potential. Now, as I told, that standard cell potential is easy to calculate because in the questions, always the reduction potential value will be given. You have to take care that formula which is given is reduction potential or oxidation potential, and as per that, you will have to please take care of the convention sign of positive and negative, and accordingly you will have to solve the numerical. But for our knowledge, which one is the good reducing agent and which one is the good oxidizing agent, we will also once go through the electrochemical series trick, how to remember it. As you have already learned in 10th standard how to remember the reactivity series of metal, here I will help you how to remember the electrochemical series by the tricks. Now, as I told, ECS, Electrochemical Series, here I have written from bottom to top. It means from strong reducing agent to strong oxidizing agent. As I told just now, lithium is the strong reducing agent and fluorine is the strong oxidizing agent. But how to remember the series? I have written for you some tricks, some tricky words that how we will remember it. Here I have considered a Kaka and Nana, they are asking for a very costly cars, and a family member is worried that if we are going to get them this costly cars, then from the next day onwards, whether we will have our money or we will be finished by all our money. So here let us remember how to remember it. Lithium Li, लिख के काका नाना मांगे, लिख के काका नाना मांगे, लिख lithium, K potassium, काका Ca, नाना Na, मांगे Mg. अल्टो पानीदार AlH2O. ज़ेन क्रेटा फेरारी नहीं ZnCrFeNi. सुनो प्रभु है SnPb है H हाइड्रोजन. क्यों इतनी आज CuIAg. हो गई भ्रमित बुद्धि HgBr. कल और सब फिनिश हो जाएगा, कल और सब फिनिश हो जाएगा ClAuF. Now let us see lithium, potassium, calcium, sodium, magnesium, aluminium, water, zinc, chromium, iron, nickel, antimony, lead, hydrogen, copper, iodine, silver, mercury, bromine, chlorine, aurum gold and F fluorine. This is how you will remember the ECS. लिख के काका नाना मांगे अल्टो पानीदार, ज़ेन क्रेटा फेरारी नहीं, सुनो प्रभु है, क्यों इतनी आज हो गई भ्रमित बुद्धि, कल और सब फिनिश हो जाएगा. My dear students, this will help you at a glance that which one is the strongest reducing agent and which one is the strongest oxidizing agent, and will help you to find out which one is the cathode and which one is the anode in your given question. Right? Now let us go further. This was about the standard reduction potential by the help of Electro Chemical Series. But earlier I told cell potential is also calculated by the basis non-standard reduction potential. Standard reduction potential was by the help of SHE, Standard Hydrogen Electorde. But non-standard reduction potential is given us by Nernst's equation. Nernst, he has given the idea about Gibbs energy as well as equilibrium. So here, at first he told us that in galvanic cell, the reaction takes place is spontaneous reaction. When I say spontaneous reaction, it means the reaction which is taking place by its own. Work done is by its own. On the other hand, non-standard reduction potential, so condition is non-standard. It may be all condition will be non-stable, or it may be any one will be stable and other will not be. As I have written here, temperature is standard, but pressure and concentration, they are not standard. But as it is galvanic cell and spontaneous reaction, work is done by the cell itself. Now, looking to this work done by the cell itself, Nernst has given us an idea that work done by a body itself is equal to the charge developing with the voltage. Flow of charge developing with the voltage. That is the work done. But here work done in the galvanic cell is by two ways. One is the electron transfer, and another I can say, if the cell is working, then energy is used up. That is the Gibbs free energy. So Gibbs free energy is reduced. It means it is negative. So minus delta G. Now if I say work done is electron transfer, then what is that electron transfers carrying the charge? So charge on 1 mole electron is considered as 1 Faraday. 1 Faraday is equal equal to 96500 coulomb. It is the standard value. It is actually 96487, but as per the international unit, it is now taken 96500 coulomb. Now if the electron transfer is to be considered for the different cell, so let us consider it is as an N, that is a number of electrons. So it will be NF, which is taken as charge Q. And as I told that voltmeter is giving us the reading of the E cell. So voltage is equal to E cell, which will be taken as V. So as per our physics formula, work done is equal to flow of charge with the voltage. Now as Q is equal to the number of electrons, charge on number of electrons, that is NF. So Q is NF and V voltage is the value of E cell, that is cell potential. And this is our first equation. And also I told work done is by the galvanic cell. So energy is reduced, and if energy is used up, it is Gibbs free energy getting reduced. So minus delta G. So your second equation here is W equals minus delta G. Now you compare equation 1 and equation 2. W Q into V, W minus delta G. Then you will get delta G is equal to minus NF E cell. And for standard condition, delta degree G is equal to minus NF standard cell potential A degree cell. This is the first equation given by the nurse when non-standard reduction potential has to be calculated, when the condition is not standard for all the temperature, pressure and concentration. Two more way also he has given us by the use of the thermodynamics with equilibrium. So that I will give you in the next video. By the time, thank you. I will upload the notes hereafter. Please go through it and wait for the next video. Again I am requesting all my dear children, please watch all the video properly and go for the notes properly. In between, I will give the questions which you have to write the answers by the help of the video as well as notes. Whatever the doubts you come across, please don't hesitate and call me for the solution. Thank you once again.